Objectives are we're going to state the volume postulates. So these are just, formulas, and we're going to apply the volume addition postulates to solid. And so this is going to talk about, in real life, when we look at solids, they're not always our perfect three-dimensional figures. They're usually combined with other figures together, and we have to add the volumes together. We're also going to look at volume formulas of various solids. Okay, so let's just review what a volume is. So volume of a solid is the number of cubic units. So think of little cubes that are 1 by 1 by 1 needed to fill up the interior completely. So the volume postulate says that every solid has a volume, and that volume has to be a positive, so it cannot be negative. Volume will never be negative, and it also has to be a real number. It's never going to be an imaginary number. All right, so we do have a congruent solids postulate, and that says that if the solids are congruent, they are going to have the same volume. Now we're going to talk about the volume of a cube. So the volume of the cube is the length of one edge cube. So if you let one edge be e, then you're going to do e cubed, and that's going to be the volume of a cube. All right, so let's talk about the volume addition postulate. If the interiors of two solids do not intersect, so they're kind of on top of each other, then the volume of their union is the sum of the volumes. So again, union, think about union. Union means to add them together. So you're going to sum up the volumes. All right, let's talk about the formula for the volume of a rectangular prism. A rectangular prism is a product of the length, width, and height. So remember, for it to be rectangular, it's got to be made up of rectangles, right? So the volume is the length, the width, and then how tall it is. So if this is a rectangular prism, correct? And so if we wanted to find the volume, we would need the length, which would be 4, the width, which would be 6, and the height, which would be 5, right? So we're trying to figure out, remember, we're trying to figure out how many cubes, 1 by 1 cubes, it's going to take to fill this prism, right? So we know that it's going to take 4 cubes across because that is the length, right? And then we're going to have 6 of those because that is the width. Okay, so we already have a 4 by 6. Oh, and that's kind of area, right? The area of that rectangle right there. So the way volume works is that if you can get the area of your base, you can multiply it by your height, right? Because think about it, length times width is the formula for area of a rectangle. So the volume is length times width, or your area of your base, times your height, right? Because we're going to take that 4 by 6, and we're going to have 5 of them, right, to fill up the whole space. Okay, so volume is length times width, 4 times 6 times 5. So we get 120. And remember, our units had to be cubed. So if this was in centimeters, it would be centimeters cubed. The yellow piece, okay? So the yellow piece, we've got a length of 4, and we need the width. Well, the width is going to be 5 because, again, it matches this piece, which is 5, right? So the width is 5, and we have a height of 12. So length times width times height, we end up with 240 units cubed. So we're going to add all of the rectangular prisms together, and we get 90 plus 250 plus 240, which gives us 580. Remember, it has to be units cubed. All right. So that's it for your notes. However, I wanted to go ahead and look at some of the problems in the book. So if you want to turn your book to section 11.1, these are the problems for that section, okay? And I just want to talk a little bit about them so you can understand them a little more. So number 1 on 11.1 says find the volume of each solid, and you have a cubed, right? Well, remember, a cubed is the edged cubed, right? E cubed, right? Since our edge is 4, well, we have 4 cubed, so we end up with 64 units cubed. So number 3 in 11.1, you have a rectangular prism. So remember, that's length times width times height. So you get 7 times 2 times 5, and we get 70 units cubed. All right, number 5, it says find the volume of a cubed with edge x. So we don't know the actual number for the edge. We're representing it with x. Well, our formula is volume equals e cubed, but we don't know what e is. In fact, we're letting x be e. So our answer would be volume is equal to x cubed cubic units, right? Or units cubed. All right, so number 9, they want us to find the volume of this cube, but they don't give us an edge. All they give us is a diagonal. Oh, goodness, okay? But remember, the diagonal is forming a right triangle because a cube is made up of squares, which means we can use Pythagorean theorem. Because if you're looking at it on top, you'll notice that we have a triangle. So we're going to use s squared plus s squared is equal to 10 squared, since that diagonal makes up our hypotenuse of that triangle. So 2s squared is equal to 100, which means s squared is 50, which means s is the square root of 50. Okay, so that's the side. Okay, that's one edge is the square root of 50. Well, you can simplify that and say, well, the square root of 50 is the same as saying 5 square roots of 2, right? Don't stress if you don't know how to do that. You can leave it just as the square root of 50. That's fine. So now volume is equal to s cubed, right? And or e cubed. And we figured that s was the square root of 50, or 5 square roots of 2. So we're just going to let that be s. So we've got 5 square roots of 2, or you could have the square root of 50 cubed. Okay? So plug into our calculator. We end up with 353.553, and it continues on. Okay? Stop. Okay. So s is equal to the square root of 12. Remember, if we want to find the volume, though, we have to cube it after that. So you will put into your calculator the square root of 12 cubed to find your answer. Did not finish that one for you. You're going to finish that one on your own. All right, number 11. So number 11, again, it gives you a diagonal here. Okay, gives you diagonal here, does not give you the width though. And it gives you diagonal here though, but does not give you the height. But notice that you still have triangles, so you can find the missing width and the missing height. Okay, so to find width, we'll do 3 squared plus w squared equals 5 squared, right? And so go ahead and do the math, and then w is going to be 4. Okay, so we know w is 4. Now we're going to do height, right? So that's formed by another triangle. So 5 squared plus h squared equals 8 squared. Do the math, and then h is equal to the square root of 39.94 units cubed. I would even round that to 75. All right, this one. Okay, so notice how there is a gap right here. Okay, there's a gap. So when you're calculating the volume of this, we cannot just do length times width times height because there is a hole in the solid, okay? So the first thing you want to do is just calculate what the volume would be if it was a whole solid. So we would have 9 times 3 times 7, right? And so it would be 189. But now we have to account for the hole. So then we're going to get the volume of the hole. And the volume of the hole is 3 times 3 times 4. So the volume of the gap is 36. So we're going to subtract that from the whole thing. So the volume of the solid is 189, which was everything, minus 36, which was the missing part. So we get 153 units. All right, let's look at this guy. Remember, you're going to break it up into triangle or to individual rectangles. So here's one rectangular prism, here's another, and here's another. So once you do that, you have to get the dimensions of each rectangular prism, and you're going to have to some of them you're going to have to figure out based on the other things. So here are all the missing pieces. to those rectangular prisms, and hopefully that will help you out when you attempt number 14. Okay, thank you very much for